Mid-August 2026 marked a collision point in the AI industry. On one side, frontier models pushed capabilities higher and compute costs lower. On the other, international regulators activated strictly enforced compliance frameworks. Right in the middle of this squeeze, Meta released the public API endpoints for Muse Spark 1.1. The core appeal for enterprise developers is clear: native tool orchestration at a 40% inference cost reduction compared to previous generation checkpoints. But deploying this cheaply comes with immediate legal stakes. The European Union has formally activated Article 50 transparency obligations. This mandates strict, verifiable disclosures for any high-risk AI deployments operating in European markets. Today, we are going to build a native tool orchestration agent that balances Meta's cost efficiency with mandatory EU and US NIST compliance headers. By the end of this walkthrough, you will have a legally viable, production-ready script. Step 1 is environment setup. Before writing any code, verify that you have an active Meta developer account with billing enabled, and open up your preferred local Python IDE. Next, configure your environment variables. You need to securely store your authentication keys so your local machine can safely handshake with the Meta ecosystem. This code editor shows the specific URL string you need to use. It is critical that you route your client strictly to the newly deployed August 15th public API endpoint. If you default to the old addresses, you will miss Muse Spark 1.1 entirely and end up paying legacy pricing. With the URL set, execute a standard ping cast against this new endpoint to validate your configuration. Once your terminal returns a successful 200 OK status, your environment has officially moved from an isolated local state to a live integration. Your setup is ready to receive complex orchestration commands. With the connection established, you need to configure the agent. Advanced models like Muse Spark 1.1 rely on native tool orchestration. This means structural data integration has replaced traditional text-based prompting to tell the model how to use external tools. Looking at this screen, you can see the strict JSON payload required by the API. You must format your tool descriptions into this exact structure to grant the model access to your external computational functions. Do not use conversational hacks. Unstructured text will break the framework. Stick entirely to these key value pairs to grant access to your external computational functions. Take this verified payload and inject it directly into your active Python script's request body. Utilizing this strict JSON formatting forces deterministic tool execution. It strips away the unpredictable nature of conversational responses, giving you reliable, repeatable enterprise automation. These algorithmic calls consume physical compute resources at a massive hardware scale. Because of this high-density infrastructure overhead, inference costs dictate whether an enterprise deployment is financially viable. To measure your actual costs, initiate a 10,000 token test batch using the official benchmark evaluation scripts. Before August 15th, previous generation checkpoints established a legacy baseline operating cost of $5 per 1 million active tokens. The left side shows the old $5 rate, while the right reveals the $3 benchmark. To calculate localized savings, divide your total active tokens by 1 million and multiply by 3. Achieving this validated 40% efficiency gain crosses a critical threshold. It takes high-frequency agentic loops out of the realm of cost-prohibitive R&D experiments and makes them practical for scalable production workflows. With costs optimized, we must address compliance. Ignoring the August 15th regulatory activations from the European Union and the US AI Safety Institute carries immediate operational risks, including automated blocking. To mitigate this, modify your script's response header handling. You need to append an official AI-generated content watermark to every output. This specific JSON template on screen provides the required structure to satisfy the EU Article 50 transparency obligations. Insert this block into your header configuration. Next, attach a basic autonomous execution logging function to your script. This aligns your agent with the new US NIST auditing criteria for tracking independent model actions. Run your completed script one final time. Check the printed console output to verify that both the EU and US metadata tags are properly appended to the response. Securing these specific metadata headers shields your underlying infrastructure from automated EU blocking and guarantees your application will pass during US enterprise compliance audits. You have successfully initialized the endpoint, configured the native orchestration payload, validated a 40% cost reduction, and locked down your regulatory compliance headers. Modern software engineering requires exactly this balance. You have to aggressively optimize algorithmic costs while maintaining strict adherence to complex international frameworks. You've successfully deployed, measured, and secured your first next-generation AI agent. Subscribe to the AI Vanguard to stay at the cutting edge of industrial AI. If you found this synthesis valuable, please like, comment, and share.